Hello, an overview of computer vision and deep learning in computer vision. For the solving computer vision problem, we have four different steps: scientific, statistical, engineering, and data-driven. And for validate your program, you need to test on the clean data, then you need to test with the noise, and then you need to test your program with real-world data. For the computer vision, we have many different type of category or classification for the computer vision program. For example, this is a way based on the frame, we can detection, classification, segmentation, feature extraction, and recognition. Between several frames, we can tracking and counting or some other cases. For the high level, we have intention relation and analysis. And for the image, if the camera feeds and object feeds, we have computer vision. For the video, camera feeds, object moving is a video analytic. For image, camera moving, object feeds. We have for example, camera on the car or bicycle or a scooter. And the use case, for example, finding the parking. For video, when we have a camera moving and object moving, like a drone, we can use the use case drone for the people. And for the dynamic environment, dynamic camera and dynamic object in complex sense, we can use multiple camera. Okay, AI, artificial intelligence, is a very huge topic, and the computer vision and the deep learning is a subcategory of AI. Can make it. Machine learning is a subset of AI, and reinforcement learning is an area of machine learning, and deep learning is area with machine learning that we have a lot of data with many different layers, and transfer learning is an area of machine learning that we use the previous knowledge for the next knowledge to train. Here category for the deep learning, we have a machine learning, and the deep learning is a part of machine learning. And for the machine learning, we have three different parts. We have a supervised, reinforcement, unsupervised, and GAN. And after we discuss about this, we discuss about tools, pre-trained models, how to train your deep learning model, optimization, hardware, and something about the programming part inside each deep learning model. A starting point, many years ago in 1993, there is a video about the recognition, the handwritten digit by using the machine learning, and you can go through the videos on YouTube and see the previous version of machine learning. Okay, let's start with the Supervised learning. I better put it here. Okay, in supervised machine learning, we have a data, we have a label data, and we know the result. So the machine learning try to understand the data based on the label data that you have. So if you have a ground truth of the data, you can use the supervised learning. CNN is one of the famous method in Countervision for supervised learning. We have an input is an image. We have a feature extraction into many layers. And after that, we have a fully connection layer is a machine learning previously version. And at the end, output, we have a softmax in order to classify your data. This is what is a convolutional neural network. And the convolutional is a layer. And let's see here. Yes. In the convolution, we have a window size, and based on the window size, we learn features, important features of the input image, and pass it to next layer, and each layer understand different kind of features. This is as an example. For example, this is in this layer, we understand the age or some basic information about the color of the input. And in the next layers, we understand much more information about the images. Activation function. After each convolution, we have an activation function in order to have a non-linearity function for the machine learning. As you can see here, we have an input, convolution, and ReLU is one of the activation function that after convolution we use activation function. And there's lots of different activation function, and one of the very commonly used model is the ReLU. And here's the formula for each of them. Activation function try to separate the most important part of the input of the convolutional layer. Then we have a pooling. In the pooling, we use the pooling for reduce the amount of the data for the process and reduce the size of the image for each layer in order to have a less number of parameters need to calculate, and is just select the most important information from previous layer to the next layer. And for example, one of the famous method for the pooling layer is a max pooling, is a window based 2 times 2, select the maximum number of these two and put it to the next layer. We use max pooling for two main reasons. One of them for reducing the computational and reduce the number of parameters to process, and also is provide translation invariance in the training for the machine learning model. In the new machine learning training model, we use dropout in order to much more generalize the model. The drop of turn off some of the nodes during the training, and then by using this, we have a much more general machine learning model. Some of the application for the CNN, for example, is a object detection. Before deep learning, we have a handcraft features like sieve, surf, and so on, and we use that one for recognize the object, but in the machine learning, we have a deep learning in order to understand each different object. For example, this is the sieve. And comparison between each other method. All this method is based on the traditional computer vision. Then we have a object detection by deep learning. In the object detection by the deep learning, we have a different various. We have a classification, just classify what's the object inside the image, for example, the cat inside the image. We have a classification and localization. We have a bounding box around the object. We have object detection. We have a we can select, understand all the objects inside the images, and we have an instance segmentation. All the pixels belonging to that object recognized. Here's the list of some object detection method for the traditional computer vision application, like sieve. One of the famous method is a sieve. And for the deep learning model for object detection, we have a RCNN, SSD, YOLO, and many more different algorithm and methods. You can see the list of them. And here's the comparison. The fastest one is a YOLO, and the mobile net-based YOLO is working on Raspberry Pi, for example, is very fast for IoT devices. This is for visualization. If you want to see what's happened between each frame and each layer, you can use this URL, this paper, and this source code. They have a lot of research how to see what's happened inside each layer. Style transfer is one of the use cases that we can use. The model trained based on the different type of painting, and then transfer the webcam to the based on this painting that trained. Okay, now we go for next one is a deep reinforcement learning. Okay, this is it. Usually you read and listen to some of the news about deep reinforcement learning related to the game in the computer, and for example Go or other game. DeepMind, one of the famous company in this area, they produce a lot of algorithm and methods for deep reinforcement learning. Inside the deep reinforcement learning, we have agents, we have an environment. Based on the action, the environment change and the state change. Also, the agents receive the rewards. The aim of the system is a increase the rewards for the whole process. So the agents try to do some action and get the more rewards. It's completely automatically. You don't need to program or something based on try and error. understand the environment and what's the best solution for solving this kind of things. Some of the use case is used for autonomous drone, for example, is object detection. They use for moving the robot arm and so on. There's many different use cases. And DeepMind, as I mentioned to you before, DeepMind, one of the famous company, they produce a lot of output program papers in this area. You can go and search about it. End-to-end deep reinforcement learning based on the Atari game and Google DeepMind work on it, and you can download Gene is a framework from Google that play Atari game and many games based on the deep reinforcement learning, and you can use it for your program or algorithm. Also, MATLAB has a lot of documents in deep reinforcement learning, and you can go to the website and download all the code and resources about it. Okay, now we go for unsupervised learning. In unsupervised learning, we don't have label data, we don't have any reward or goal for the system to understand the behavior, and so we don't have any label, we don't have any reward. The system automatically must be classify the data automatically without any prior knowledge about the ground truth or label data. We have many use cases for unsupervised learning. One of them is for compress the data, decrease the complexity or dimension of the data. And autoencoder is one of the famous algorithms in this part. The autoencoder receives the input image, and the output is the same, must be the same image. So the deep learning model try to compress to this layer and decompress the image to go back to the same input images. So later on, when you use this layer, you have a much compressed version of the data. About autoencoder. GAN, one of the famous in the deepfake, and some related to generate data is a combination of the two networks. And these two networks, one of them try to understand the data, another one try to create a data same as the input data. So here, for example, this is use cases. You draw something here and automatically generate the image based on this drawing that you have. Is basically you have a two network, one of them using for generate data, one of them used to understand this generate data is true or not. Another use case is a super resolution. You can increase the resolution of the images. Another one generate a face. Okay, let's go for tools. For the tools, we have a many different library you can use. We have a library for TensorFlow from Google, PyTorch from Facebook, and XAVIER from Berkeley AI Research. AutoML try to automatically parameter tuning for you. Amazon, Google, PyTorch, and all other frameworks have a different open source free library to use. And environment for deep reinforcement learning, as I told you before, OpenAI Gene you can download, or DeepMind Lab. and there's some other tools. Pre-trained model. If you go to this website, there's a lot of people, they train the model based on many different use cases. You can go through and search it and find most related model for your use cases. And if you can find a similar, you can fine-tune the model based on your new object or new area of the research for the deep learning. This is the effective how to train your deep learning. Usually you have a small number of data set. You need to increase this data set. Data augmentation is a way to increase your data to the much more data. Just by a few tweaks to the images, we can increase number of data to train. Fine-tune, when we have a trained model, we want to fine-tune it for new object. For example, the model trained for 1000 object detection, and you have a new object you want to classify, for example, different car, and that kind of car doesn't exist to the car detection model. So you create a data set and fine-tune that previous model based on your new car. Here's a comparison and a comparison. We have a lot of different methods for optimize your deep learning. For example, binary deep learning use 0 and 1 as a binary, not a float point 32 bits. So is memory reduced and the network is much more faster, but the accuracy a little bit lower. And we have many different methods for optimize your deep learning model. The hardware that we use for the training, you can use AWS, Google Colab, and other open source cloud-based training model. Or also, if you want train on your laptop, you need to have a Nvidia graphic card. And for Nvidia graphic card, I suggest use this four. This two is based for the laptop, and the first two is based for the desktop. Although some laptop may use this high-end desktop version of the Nvidia, but RTX 2080 Super is one of the latest version of the Nvidia graphic card for the laptop, and for the PC you can use GeForce RTX 2080 Ti. This is 8 GB of memory and is very good for training. Here's machine learning in 2020 based on the Gartner and so on, some use cases. This is about how to build your deep learning model. Later on I will discuss to you. And yeah, I see you next week.